Okay, so now we can actually take the law of sines and apply it to real world problems. So this shows the map of a path a pilot flew between Omaha and Chicago. So in order to avoid a thunderstorm. So this particular pilot flew from Omaha here to Chicago, but couldn't go straight through, couldn't do a line, he had to fly in an opposite direction, had to go around the storm. So had to go this way and this way. The question is, how much longer is this than the direct route to Chicago? So I need to find this measure and I need to find this measure. So that means I'm going to have to use the law of sines twice. So the first one here is just going to be the law of sines, and we can find x first. So our law of sines would say that the sine of 22 degrees over x is equal to the sine of 113 over 471. The sine of 113 degrees over 471. Now we cross multiply and we get 471 times the sine of 22 degrees is equal to x times the sine of 113. We divide by the sine of 113 degrees. And this over here is what I'm going to put into my calculator. So let me put that in our calculator and then we will insert that snapshot right here. So when I plug that into Desmos, we see over here that that's about 119.67. We are going to round that to the nearest tenth. So we can say that x is equal to 91.7. So that would be our x, which is right here. So that's 191.7. Now we need to find our y. So let's see what that looks like. Okay, so to find our y, we'll go in blue for that one. We're going to do the same idea. I'm still going to use that sine of 113 over 471 that I used before because that was already established. But now I'm going to need to find this angle as well as the y. Well, remember, all of the angles in a triangle equal 180 degrees. So I know that 22 plus 113 plus, we'll call that angle Omaha, should equal 180. So I can use my calculator and solve. So that tells me that angle, the Omaha angle, should be 45 degrees. So let's make that a little bit clearer. So this angle, Omaha, is 45 degrees. Now I can use the law of sines to find angle y. So I know that the sine of 45 over y, side y, not angle y, is equal to the sine of 113 over 471. And again, we're just going to cross multiply to solve this. So I get 471 times the sine of 45 is equal to y times the sine of 113. So I'm going to divide by the sine of 113. Those cancel, and now this is what I'm going to put into Desmos on my calculator. Okay, so we can see when we plug that in, we end up with that y is equal to about 361.8. So y is about 361.8. So I'm going to put that up here. 361.8. Now, the question actually asks, how much longer is the route? So now we have to do a little bit of interpretation of what's going on. So off here, last thing I'm going to do is I'm going to look at the total path that the airplane flew was 191.7 plus 361.8. So I'm going to use my calculator to come up with that total. And you can use your handheld calculator, your phone, or Desmos. And that's 553. And we do have to remember we are rounding a little bit, so it's not exact. And the actual flight would have only been 471 miles. So now I'm going to do 553.5 minus 471. And so it's an additional 82.5 miles would be my final answer. So how much longer is this route? It's an additional 82.5 miles longer to fly this route than it would have been to do a straight shot, except for that dang storm. So there you go. There's one just like this. That's a try it problem that we will do next.